Okay, 2A, we're going to talk about understanding, solving, and explaining a problem, as well as using it to help look at unit analysis. So the first thing we look at any kind of word problem is you need to know what is it that they're asking. So that's the first step, is to understand. You need to know what exactly do they want to know. Specifically, what kind of units do they want? Do they want like a number of hours? Do they want a speed in miles per gallon or miles per hour? Like what exactly do they want to know? You also need to know what information they give you, and you're going to use that information to then solve the problem. Now you can do this in different ways. We'll talk about different methods to solve it. And once you have actually come up with an answer, you need to make sure that you can explain the result. Be able to put it in a sentence, be able to make sure that it actually does make sense in the context of the problem. Okay, so now let's start looking at an application of this. So because we're looking at real world situations, we are going to use units. So when we have numbers, they're not just numbers, right? So they have to have something along with them. Number 5 would be 5 apples, $5, 5 hours, etc. So units are words that describe what is being measured or counted. Units are crucial. You have to make sure that you know what kind of units you're looking for. So unit analysis then is going to be the process of working with those units. Because sometimes they give you information in a unit that you don't really want, something that's not quite as useful, so you need to be able to change stuff around or even combine information to get the thing that you want. So we're looking at units. We're mostly going to be looking at it in fraction form. And we'll, so for example, like when we have like 12 inches is equal to 1 foot, we'll write that in a fraction, 12 inches to 1 foot, and I'll show you why we can do that in just 1 minute. Okay, so keywords here that you're going to see quite a lot is per. Per in math is going to mean division. For example, miles per hour, which is the same thing as miles divided by hour. Okay, the word of or a hyphen is going to be multiplication. So for example, if you have 20% of 100, that is going to be 20% times 100. You may also see a hyphen in something like kilowatt hour, and that is going to be a kilowatt times hour. When you have a square, that means you're going to be raised to the second power. For example, square feet. When we're talking about area, is going to be feet squared. And then cubic is going to be raised to the cube. You can think of this as a 2-dimensional and 3-dimensional, right? Because a square is a 2-dimensional object, a cube is a 3-dimensional object. So if we have cubic feet, that's going to be feet cubed. Okay, and back to what I was talking about with the fraction. They're called conversion factors, where you have two things that have different units but they equal the same. So like 12 inches is equal to 1 foot. Well, in math, remember, you can multiply or divide by the same thing on either side, and you will still maintain equality. So in this case, let's say we divide both 12 inches and 1 foot by 1 foot. We then have this equation here. So 12 inches divided by 1 foot is equal to 1, because 1 foot divided by 1 foot, something divided by itself is just 1. And note that there's no units for the 1 because the feet would cancel out. In this case, it works a lot like variables. Now we can do the same thing, or similar thing, we can divide both sides by 12 inches, and we get 1 foot divided by 12 inches is equal to 1. So basically when we're doing these conversion factors, we are basically just multiplying something by 1 to get a similar fraction, just like we might say like 1/2 is the same thing as 2/4. So they're written differently, but they're essentially the same thing. Okay, so the way we're going to put these, sometimes it's better to have the inches on top, sometimes it's better to have inches on bottom. And to figure out what we need, we want to set it up so that the ones we don't want are going to cancel out, and the units that we do want are going to stay there. So there's a couple different ways to do this. In the book and in my math lab, it will give you how to do it in what I like to call the forward approach, where you start with what they've given you, and you put them together in a way to get what you want at the end. But the way I'm going to show you here in this video is to start at the end and how to get back to the beginning. So I'm going to call this my backwards approach. So the steps here. So the first step is you want to start with what you want, not with what's given. You start with the destination, just like if you're doing a puzzle, you start with the picture in mind, right? So you might start with like the edges, but you always have to have what you want in mind. So you're going to set it up in a table with 2 rows. So basically you're going to have a bunch of fractions multiplied together, so instead of writing them all separately, we're just going to put them in a table. So we start with what we want, put your desired unit in the first cell, and then on the next step you're going to find a conversion factor that includes your desired unit, and you're going to put those numbers into your columns. And then if there's something that you don't want, then you're going to find that unwanted unit in your given information, and you're going to put it in there so that they cancel. And you're going to keep doing that until everything that you don't want is canceled and you're only left with the things you do. So let's look at an example. Let's say we want to convert 16 feet to yards. So what we want here is yards. What they've given us is that we have 16 feet. Notice that when we have what we want, we don't have a number with it yet. What we're trying to find is the number that goes with the yards. Okay, now to do this, we are going to need a little bit of information that they don't specifically give us, and that is going to be some relationship between feet and yards. But first, let's get with what we have here. So I'm going to set up a little table, and I'm going to add things if I need to. So 16 feet to yards, we're going to start with what we want. So we're going to put yard here. Now remember, in the real world, we can't have a unit without a number, and we can't have a number without a unit. So I need to have some sort of number to put there, and that's what the step 2 is. So I need some conversion with yards. Right now I don't have anything in here, but I know that I have feet, and so I'm looking for any kind of way to start incorporating the stuff that I have given. And I know that there are 3 feet and 1 yard. Now notice I could have written this either way. But I wrote it this way. That does not mean I can put the 3 up here and the 1 down here. I need to make sure the numbers match up with my units. So remember I said that you can put the fraction either way. So I'm going to put the 1 yard up top and the 3 feet on the bottom. And now I've used that one. Once you use a conversion, you're not going to be using it again. So I start with the yards and feet. Well, now step 3 is I'm going to look and see if I finished everything. I'd have a yard in the numerator and feet in the denominator. Well, I don't want feet in my answer, right? I only want yards. So I need to cancel out the feet. So just like in algebra, if you have something in the numerator and denominator that matches, then they cancel out. So I know to cancel out the feet, I have to have it in the numerator and denominator. Well, now I have a unit without a number, so I have to find something that has feet in my given. Well, I have 16 feet here, so I'm going to 16 here. Now, because it's just 16 feet, just a basic measurement, it's not any part of conversion, or it doesn't have a relationship or anything, I don't have to put anything down here. So now I've got feet canceled out. The only other units that I have in my answer are yard, which is what I want, so I can go ahead and do the last step, which is to multiply across. multiply each row, so 1 times 16 is 16. 3 times nothing else is just 3. So then I can do 16 divided by 3, and I get 15 1/3 yards. So 16 feet is the same thing as, not 15, I'm sorry, it is 5. Sorry about that. Okay, 5.3. So that's one of those things where, like, in that case, I saw 15.3 goal. That was almost exactly what feet I had. And you know, there's 3 feet to a yard, so that was a little bit iffy. That's how I know I made a mistake. Okay, looking at another example. Now let's say we're converting 17 years to days. Neglecting leap years, so we don't have to worry about, you know, that year having an extra day. So I know I want days. And what I have is 17 years. And I'm going to go ahead and write the conversion I know between days and years, because I know somehow I have to get between the two. So I know that 1 year is 365 days. Okay, so starting my table, I start with what I want, so I start with days. Look and see, what do I know about days? Well, I know that 365 days is equal to 1 year. So the number with the days is 365 as 1 year. And now I have years in my table here, but I don't want them, so I need to put a year on top so that I have one on the top, one on the bottom, so they will cancel. And now I have 17 years. Nothing else with it, so I don't have to go anything below here. Now years cancel. Remember, it's just the unit and not the number that cancels. Now we're going to multiply across. So we have 365 times 17 to get 6,205. Just 1 on the bottom. So 17 years is equal to 6,205 days. Okay. Now both of these we only have the one step. Sometimes it takes more than one step to get there, especially if we don't want to look up an additional conversion. So here, they want us to convert 45,789 inches to miles. So what they want is miles. What they give us is 45,789 inches. And then of course we need to get from inches to miles. Well, I don't know that conversion offhand, but I do know there are 12 inches in 1 foot, and I know there are 5,280 feet in 1 mile. So I start with what I want. I want miles. So what do I know about miles? Well, I know 1 mile is 5,280 feet. Now I have feet in my answer, but I don't want it, so I need to put feet here. Let's see if I can get rid of that. There we go. Maybe. Okay, so now I need to get rid of the feet, so I need something else that has to do with feet. I've already used that one, so I'm not going to use it again. Well, I have this foot here. So I have 1 foot is 12 inches. So my feet cancel. So now I have miles and inches. Well, I don't want inches, so I need to put inches up here. I already used that one, so I only have this one left here. So 45,789 inches, and it's just measurement, so there's no units with it. So my inches canceled out, feet cancel out. The only units I have left are miles, which is what I want. So I multiply everything across. 1 times 1 times 45,789. And then 5,280 times 12, which I didn't write out for some reason. 5,280 times 12, and we get 63 360. And then if we actually do that division, then we get 0.72 miles. Now if you don't want to do them separately, you do have the option of multiplying everything on top, and then you can do either in a calculator 45,789 divided by parenthesis 5,280 times 12, or you do 45,785, so whatever you get on top, you divide it by 5,280, you get that answer. And then you take that answer and you divide it by 12 again. So let's see, what is the answer? 45,789 divided by 5,280. 8.672. And then in your calculator, once you have that in your thing, if you just hit the divided by 12, it'll fill in the answer for you. Okay, now let's look at what happens if we aren't dealing with this one-dimensional units. Well, what if we have units raised to power? So that's your square feet, cubic feet, anything where we're looking at area or volume. So to get the conversion factor, we have to adapt the conversion factor. So let's say we want to find the area in square feet of a 100-yard by 60-yard football field. So just to picture this, so we have 100 yards here and 60 yards here. What we want here is area in square feet. So we want some number with foot squared. And they give us that the length is 100 yards and the width is 60 yards. And then of course to find the area, we know the area is going to be the length times the width. Okay, so if we actually found out the area in square yards, then we can find the square yards and convert it into square feet. So 100, so we 100 times 60, which is 6,000 square yards. And that is the area of this football field. So we're given 6,000 square yards and we want that area in square feet. Now I can't just say 3 feet is 1 yard, so 3 square foot is 1 square yard. It's very tempting to just add that little 2 there, but it really makes a big difference. Because if we remember, we're talking about area. So let's say we have 3 feet by 3 feet square like we have here. So the length is 3 feet and the height is 3 feet. So if we found the area, that would be 3 times 3, which is 9 square foot. So the area of this square is 9 square foot. However, we also know that 3 feet is 1 yard. So we can say it's a 1 yard by 1 yard. So it's 1 square yard. So we can say, if we start with the regular unit, to get to the square conversion, you take this and you just square it. So we'd have 3 squared is 9, feet squared is feet squared, 1 squared is 1, a yard squared is yard squared. So this is now the conversion we're going to use. So we want square feet. And in my given list I have this yard squared and I have this conversion. Note that if I were to put this in a fraction, it would be 9 square foot over 1 square yard, right? If I divided both sides by yard squared. So I have 9 feet squared divided by 1 yard squared. Now I don't want square yards in my answer, I only want square feet. So I can put my 6,000 square yards here, and there's nothing else that goes with it. So yard squared cancels, so I'm left as feet squared, so I just do 9 times 6,000 to get 54,000 square feet. So the area of a football field is going to be 54,000 square feet. Okay, let's try some more examples. Okay, let's say a hot tub pump circulates 3.5 cubic feet of water per minute. How many cubic inches of water does it circulate each minute? So, what does it want? We're looking for that question word. So here it is how. How many cubic inches of water does it circulate each minute? So it's how many cubic inches. So it's going to be, sorry, I don't know why I said meters. So we want cubic inches of water does it circulate each minute. Now each is another way of saying per. So we're going to say, and per in math is division, so we want per minute. Okay, so this time we have 2 units that we want in our answer, and I'll talk about how to do that in just 1 second. First, I want to list everything we have in our given. So we're going to find each and every listing of a unit that we can find. So the first unit I see is cubic feet. So we have 3.5 cubic feet of water per minute. So per minute. Okay, and then that's the only information they give us. So when we have 2 things in what we want, we're always going to start with the numerator. Technically you can start with either one, but I like to just start at the top. So we're just going to start with inches cubed. Okay, so then I'm going to go in my list of givens, and now I haven't listed the conversion yet. So I only have feet, so somehow to get from the inches that I want to the feet that I have given. So note, we know that there are 3 feet, sorry, got caught up in my last question. From feet to inches, we have 12 inches to 1 foot. Okay, so that's the basic one. Now we want cube those. We're going to have to cube this. So this becomes 12 cubed which is 1728 cubic inches. And then 1 cubed is 1 cubic feet. So this is the conversion we're going to use. So I have 1728 with my inches and 1 cubic feet. Okay, so I want inches in my answer, but I don't want cubic feet in my answer. So I'm going to then put the other thing I know about feet squared, which is 3.5 cubic feet. Now in this case, I can't just put 3.5 cubic feet because it's not an actual, like a measurement that I have. It is a rate. So I have cubic feet per minute. So because this minute is here with the fraction here, I have to put a minute here. And since this is part of a fraction, you can assume that there's going to be a 1 in front of that unit. So it's going to circulate 3.5 cubic feet per 1 minute. So the cubic feet cancel, and now I have inches cubed in minutes. So that's why I always start with the top, because at some point you're going to introduce a unit that will get you into the unit that you want. So we now have inches cubed per minute, which is what we want. So we just do 1728 times 3.5 to get 6,048 cubic inches per minute. Okay, now let's say we have a hose that's filling a hot tub, again, but this time at a rate of 4.5 gallons per minute. How many minutes will it take to fill a 300-gallon hot tub? Okay, so how many minutes will it take? So what they want is minutes to fill a 300-gallon hot tub. Now in this case, there's no per or each in there. So this is actually going to be something different that's going to go in your given list. So we have a 300-gallon hot tub. Now going back to the beginning to see any other units, we have a rate of 4.5 gallon per minute. So listen out what we want. We want minutes. So I need to know something to do with minutes. Well, I have minutes here in my given list, and I know that each minute you get 4.5 gallons. So for each minute, I get 4.5 gallons of water. Okay, now I don't want gallons in my answer, so I look and see what else do I have about gallons, and I have 300 gallons here. I know there's nothing else in this fraction, so I don't need to put anything down here. Now all I have left is minutes, which is what I want, so I do 300 divided by 4.5. And I get 66 2/3 minutes. Now I know some of this may seem really intuitive, where you can do it without setting it up like this, but if you practice on these where you know what the answer should be, it helps you when you get to some of the more complicated ones where it's not as obvious what you need to do. So example 7, if your car gets 32 miles per gallon, how much does it cost to drive 30 miles when gasoline costs $2.55 per gallon? I wish it was still that cheap. So what we want, question word, how much does it cost? Okay, so if we're talking about cost and we're talking about us, we're in our country, we measure cost in dollars. So I don't know, how much does it cost to drive 30 miles when gasoline costs $2.55 per gallon? So it doesn't say like a cost per or cost each, so we just want dollars. And now we can put the rest of the stuff in our given. So I'm just going to start over at the beginning to look at all of our units. So your car gets 32 miles per gallon. Well, those are some units. So we have 32 miles per gallon. We're driving 30 miles. When gasoline costs $2.55 per gallon. Okay, so start with what we want. So we start with dollars. What do I know about dollars? Well, I know that we have $2.55 for each gallon. Well, I want dollars in my answer, but I don't want gallons. So what else do I know about gallons? Well, I know that 1 gallon will get me 32 miles. So I put gallon on top so that those two cancel. And this 1 gallon goes with 32 miles. Okay, well now I have dollars in the numerator and miles in the denominator. I don't want anything in the denominator, so I need to get rid of miles. So I'll put miles in the numerator. And the other thing I know about miles is that I've driven 30 miles. It's not a rate or anything, so it just cancel out the miles. Everything's canceled out except for what I want. So I do my 255, I'm going to multiply that by 30, and then I'm going to divide that by 32. And I get $2.39 for that trip. Now, does that really make sense? You get 32 miles per gallon. Well, you're only going 30 miles, so you're not going to use quite 1 gallon. 1 gallon is $2.55, so if you don't use it all, then you're going to pay less than that 1 gallon. Okay, another thing we see often with unit analysis is currency conversion. If you're ever going to travel outside the country, you're going to have to get new money in order to use it in that country. So when we're talking about converting currencies, we call that the exchange rate. So you're exchanging your country's money for another's country money. Now those exchange rates are constantly being updated. So to try to keep things simple and uniform, we're going to stick with old currency rates. So for example, here's in this table we have January of 2017, one of the exchange rates. So in this, you notice that there are 3 columns. So the first column is the different types of currency. So like we would be going from our dollar to say the British pound, or the Canadian dollar, European euro, Japanese yen, or Mexican peso. So this is currency between us and each of these. Now there's 2 different rates we can use depending on how we want our units to fall. So notice in the first one we have dollars per foreign. So this is dollars. Per means divide. Foreign is going to be whatever we have down here. So for example, this would be $1.221 per 1 British pound. Notice this one we have foreign per dollar. So this would be a foreign divided by our US dollar. So in this case, it would be 0.8191 pounds per $1. So you can use either one. It might give you a slightly different answer because these values are actually rounded. But just make sure you put the number with the right unit. So in this case, this number here is always going to go with whatever is listed first. So the 1.221 is going to go with dollars, the 0.8191 is going to go with your foreign, and so on. So let's look at examples. So example 8, your hotel rate in Tokyo is 45,000 yen per night. What is the nightly rate in US dollars? Okay, well what is the nightly rate in US dollars? Okay, nightly. That is another way, again, of kind of hiding that per. Nightly is same thing as like per night or each night. So that is going to be a per night, which means we're going to have something in the numerator, right? They want it in US dollars. They want $1 per night for the nightly rate. What they give you is 45,000 yen. And then if we go and look at our currency, we can use either one. Typically, I'm going to go with the one that is easier to write. This one, there's only 4 numbers and a dot. This one, there's 4, 5, 6, 7 numbers and a dot. So I'm going to go with this one just because it's easier to write. But again, you can use either one. So I know that there's 115.5. Now this one is foreign per dollar. So I'm going to put yen per $1. Do the conversion. I want dollars per night, so I'm going to start with my dollars, and I want alright, so this is, sorry, I made a mistake, so this is 45,000 yen per night. Forgot that, so it is per night here. It's always good to go back and double check everything you do. Something doesn't look right. So in this case, I want dollars, so I know the exchange rate is $1 for 115.5 yen. And I need to cancel out yen, so I'm going to put my 45,000 yen. So this is where I figured out I had a mistake. So if I just had the yen, I'd have nothing here, and I just have dollars. There'd be no way to introduce this night. So because this is per night, we have our 1 night here. So yen cancels, now we're left with dollars per night, which is what we want. So I do 45,000. And I divide that by 115.5 because the other numbers are just 1. And I get $389.61 per night. It's a pretty expensive hotel. Okay. Now let's say we're returning from Mexico. And we have 2,500 pesos left of everything that I spent. Now I'm going to exchange it back into US dollars. So how much are they worth in US dollars? So this is how much are they worth in US dollars. So all they want is dollars. There's nothing else they're asking for. What they give us, we have 2,500 pesos. And then of course we have the exchange rate. For pesos, we have this one and this one. Again, I'm going to use this one just because there's fewer digits to write. So say 21.86. This is foreign per dollar, so I have peso per 1 US dollar. I want dollars, I'm going to put dollars in the numerator here. Look and see, what do I know about dollars? Well, I know $1 is going to equal to 21.86 pesos. I don't want pesos in my answer, so I need to cancel it out. So I'm going to put peso in the numerator. And I know that I have 2,500 pesos, and it's just pesos, nothing else with it. Pesos cancel. I'm left with this dollars, which is what I want. So I have 2,500 divided by 21.86, and I get $114.35. And that is it for 2A.